Hey guys, Josiah from EasyCaters.com, and today I was just going to walk through. I have a request from a customer client that I thought was a simple enough little scanner project that I could do a quick video and show people how to do it, and also help him out in the meantime. So I'm going to just walk through that project. Basically, this is a scan looking for stocks with relative strength. And here's the criteria we're looking for. So we're trying to identify relative strengths in stocks compared to the SPY over a series of time. We want to scan for all stocks in industries and sectors. Minimum price to be $3. 5-day average volume to be at least 1 million shares. And then we got some other stuff here. So let's just start with the first three real quick. So scanning all stocks and industries. So we're going to do that, we're going to go up here and choose Scan In Category All Stocks. He's saying all industries and sectors and stuff. And if he's specifically wanting to scan for signals on sectors, then we would have to do this in a different way. We'd have to create a custom list of stocks and add to that the sector symbols as well. There's not a way to do a union. So you can see up here, you could do an intersection of one list with another list. There's not actually a way in Thinkorswim to do a union of two lists. And that's unfortunate because that would solve this problem really easily if we could do all stocks plus all sector symbols. But we can't do that. So if you were wanting to do all stocks and all sector symbols at the same time and scan in both, then you would have to create a custom list like over here on Market Watch, and add all of the stock symbols to it that you want to use, and then also add all the sector symbols that you want to use. And then you would come back over here to the scan and point this scan to that personal watch list that you created. And so then you could scan in that list. I'm going to assume for this purpose that he just meant that all stocks regardless of sector or industry and so forth. So that's what I'm going to assume for the purposes of this. But that's how you would do it if you wanted to do all of those. Then minimum price of the stock is $3. So this is how you would accomplish that. You can set the maximum over here to whatever you want. You can even remove it up here. And then average daily volume, let's see, I can't remember how many days. 5-day average volume, at least 1 million shares. So we're going to set this to 5 instead of 50. Simple moving average of volume greater than 1 million shares. And this is set to a daily time frame, so its daily candles have to have at least 1 million shares on average. Okay, so that's the first three criteria. Then we've got 4, 5, and 6. We've got the average daily range over those last 14 daily bars, not counting today, is at least 6% or at least $5 for the stock. So what we'll do for this is add a blank study filter. And what we're going to do is create a range variable. So we're going to say, and in fact, we'll create some inputs here. Min dollar range equals $5. Min percent range equals 6%. And I need to add my semicolons at the end of the line there. So those are our minimums that we're requiring to look the scanner to look for. Then we're going to set up some variables. Define range, and we'll call this dollar range equals, and you could define this in multiple ways, and I'm not sure, he didn't specifically mention this. A lot of times range is just defined as the close of today minus the close of yesterday. So it's basically the change of the close. But you could also define as the high minus the low. And so that would be the range of today's candle. You could also define it as true range, which is a slightly different calculation. And you can do that by just specifying high, close, low here. And we're on a daily time frame already, so it's going to take those daily bars, plug it into this true range calculation function, and use that to calculate the dollar range of the daily bars. So we'll assume true range is what he's looking for there, but you could equally say high minus low, or you could do close minus close 1, and that would look at the close of today minus the close of yesterday and give the range of the closes. Or you could do the close minus today's open, so it would just be the close to open range. And so there's multiple ways to do that. That's how you would do all those different methods. Then we're going to take that dollar range and we're going to convert it into a percentage. So we're going to say percent range equals the dollar range, and you got to decide what you're going to be relative to. So percentage is just relative to something, and we're going to make it relative to the prior close. So we'll say the dollar range as a percent of the prior close. And then we'll multiply that by 100 so it's in percentage form so we can compare it directly to this percentage value up here that we're using as an input. So dollar range that we're taking from right here as we calculated with the true range, divided by prior close using this 1 bar offset, and then multiplying it times 100 to get the percentage value, and so that gives us the dollar range and the percent range of today's daily bar. But he didn't want just the range, he wanted the average range and the average percent range to be at least these values. So now we have to add an average. Average dollar range equals moving average. And we're just going to choose an average simple, average type simple. The data we're going to use is this dollar range input or a variable that we just created. So we're going to calculate an average of that value. And then we're going to calculate it over the past 14 days because I think he said 14. So we'll add that in here. So that'll give us the average true range over the past 14 bars. Now, he also said not including today, so we want to offset this by 1. And you could do that here by offsetting the dollar range input, or you can actually do it at the end of the whole function as well. Either one works. Then we're going to do the same thing for the percentage. Average percent range. I'm just going to abbreviate that, and we're going to call this, instead of using the dollar range as the input, we're going to input the percent range. And we're going to do it for the same length and offset it by 1 day as well. So now we've got our variables created, and we've got our inputs where the user can control how many days and how, what the minimum dollar range and percent range are. And so now we're going to put it all together and put an output, which is basically the requirement that the scanner is looking for. So we're going to use a plot statement for that. And we're going to say plot scan, and it doesn't really matter what you name it here. But you can name it S, you can name it A, I mean, it doesn't really matter. Plot X, you can name it anything you want. Scan equals, and here we're just going to say average dollar range is greater than or equal to the min dollar range that the user has specified up here, and average percent range is greater than or equal to the min percent range that the user specified up here at the top. That should take care of it for us. So now we've got that criteria taken care of. So, and we could, as a note to ourselves, we could say, okay, put a little comment up here at the top, criterion number 4. And so that's kind of notating what that belongs to. So now we've got 1, 2, 3, and 4 taken care of. 6% minimum, or at least $5. And now number 5 is the price of the stock divided by the price of the SPY. Basically, he's looking at the 20-day relative strength here. He's looking at the price of the stock divided by the SPY today versus 20 days ago. How much did that, the stock appreciate as a percentage of the SPY's price? So for this, we will create a new study filter, add study filter, and we're going to create user input for the number of days, periods 20. And so now we're just going to create the variable, you can name as anything, RS we'll call it, close divided by close of another symbol, and this symbol is going to be a SPY. So the close of the stock we're currently evaluating divided by the close of a specific symbol that we're choosing here, and we're choosing the SPY. We could even give this as an input. We could say symbol equals SPY here, and let the user control that, and so we can replace this over here with symbol input equals the symbol that the user chooses up here. So maybe that's a little better code. It might be even better to name this something else to differentiate a little bit, comparison symbol, so that it doesn't look exactly like this input parameter here. Anyway, so that's our variable, and now we're going to compare the value on the current bar to the value 20 bars ago. So basically we're going to say, and we can actually just do this in the final output. The plot scan equals RS of today let's see here, RS of today minus RS of 20 bars ago, periods bars ago. The user periods here is the number of bars ago that we're looking at, is greater than or equal to, so the difference that it's gained is greater than or equal to some amount here. And so we'll just say 1. I don't actually know what we want here yet. Let's see. Okay, so this is a little bit unclear because it didn't actually say it needs to be above a certain amount, so we'll leave that for the user to define. We'll put this at maybe, maybe it's grown by 0.1. I don't know if that's a reasonable value or not, but we'll leave it there and let the user decide. And then we'll leave a note to ourselves, criterion number 5, so we know what this is. Every number except the number I want there. Okay, so and I need to also learn how to spell here, it looks like, criterion. There we go. And so I think we just have one more left, and that is criterion 6. Have a column with a value for the number 5 above appear in the scan. So basically he's just wanting the okay, so he's wanting number 5 to appear in a column so we can sort the list by that value. So what I'll actually do here is, since he's not provided a value, I'm just going to say it has to be greater than or equal to 0. And so that's saying there has to be strength, there has to be growth here instead of shrinkage, basically. It has to be a positive output value. We can also give this as an input, min value equals 0. And so the user can just specify that up here, and it will automatically apply to the scan. So relative strength minus relative strength 20 bars ago equals this 0 minimum value. So the user can set that however they want. Now we're going to take that calculation and put it in a custom column. So to do that, we're going to right click somewhere on the columns up here, choose customize, and we're going to find some custom column that we don't need anymore. Sometimes Thinkorswim will come with like custom 1, 2, 3, 4 that you can just use for whatever you want. I've already used all those, so mine are all already renamed some other things. So I'm going to look through here for one that I don't need presently. And we'll just add that. I think that's probably a good one to choose. Prior close, that seems easy enough to replace if I... so I'll just paste that in here, and I'm going to change this to a daily candle time frame. And this is criterion number 5 and 6. And we'll call this RS. We can call it RS20. And so now we're going to take this calculation and just plot it. We don't have a specific value we're looking for in the column. We're just wanting to plot the value in the column. And I did this wrong. So RS, we'll just name, so we've got the variable here. now we're going to output it. So I'm just naming the plot X. It doesn't really matter what you name it. And then we're going to plot the difference between the RS on the current bar versus the RS 20 periods ago. And I'm going to take out this criteria here for it having to be a certain amount. And so it's just going to output the difference in RS over the past 20 bars. And so with that, we should be able to, delete that note here that I had to myself to keep track of what I was doing. So I'm going to delete that filter. And everything else should be set up how it should be. Now, I don't know if we're going to get any results from this or not. Looks like we did. And so this tells us what the results are, and this is allowing us to sort the strongest to the top. So you can sort the list by that, and it will bring the strong ones to the top and the weak ones to the bottom. Another thing you could do here is color it and say x dot assign value color, and say if x is greater than or equal to 0.1, then color dot light green and I'll space this out and make it a little prettier. Else, if x is greater than or equal to 0.05, then color dot dark green. Else, if x is greater than or equal to 0, then color dot gray. Else, if x is less than or equal to 0.1, negative 0.1 that should be, then color dot light red. Else, if x is less than or equal to negative, I'm just going to do the same exact thing in reverse, then color dot dark red. Else, color dot dark gray. So the catch-all color for anything that remains after that is just dark gray. So this should color through, so you can see this is above 0.1, so it colored it green. This is not quite 0.05, so it colored it gray. This is above 0, so it colored it gray. So that's how you would customize that a little bit. And so now hopefully you can see how to do a scan like this and what you need to do if you want to customize this in other ways. This is kind of the approach I would use. Hopefully this is helpful to somebody, and especially to the gentleman that requested this. And anyway, I hope that helps, and I will talk to you guys next time. Thanks.